Okay, welcome to another marathon episode. This time the topic is equations of circles. Equations of circles was added to the syllabus in 2020, which means that there aren't a lot of older past paper questions. The questions appear from 2020 onwards. So, what I'm going to try to do today is try to solve as many past paper questions as possible in the recent past papers. So, this is March 2020. And the first question says the diameter of circle C1 has endpoints minus 3 comma minus 5 and 7 comma 3. I've always found it useful that to draw the circles and then to point out 7 comma 3 should appear somewhere here. So that looks like the endpoint. It says find the equation of the circle C1. Now if you remember from the lecture, x minus p whole square plus y minus q whole square equals to r square is the equation of a circle where p comma q is the center of the circle and r is the radius. So the two things that I need to do here is calculate the midpoint. If there are endpoints of the diameter, then the midpoint should be the center of the circle. Minus 3 plus 7 divided by 2 and minus 5 plus 3 divided by 2. That gives me 2 comma minus 1. So that's the center. So I'm going to write x minus 2 whole square, y plus 1 whole square. Now for the radius, what I need to do is calculate the length of this diameter and then divide it by 2. So in order to calculate the length, I'm going to apply the length formula. That's d 3 minus minus 5 whole square, 7 minus minus 3 whole square, and that should give me what? It should give me 8 square plus 10 square. That gives me root of 164. Root of 164 and then divided by 2. Okay, I know that it gets squared, so I don't really need to worry about a lot of things here. I can just put this inside a root, divide by 2 and square it. That gives me 41. So the equation of the circle is x minus 2 whole square, y plus 1 whole square equals to 41. I am hoping that's the correct answer. Let me just open up the marking scheme and keep it here so that I can review the answers as I do them. Okay, that's paper 1 and I'm solving March 2020. This is question number 12. Okay, yes, that's the correct answer. I'll just keep the marking scheme open for future questions as well. Okay, this says the circle is translated 8 4 to give circle C2. The circle C1 is translated by 8 4 to give circle C2 as shown in the diagram. Find an equation of the circle C2. Now the important thing to notice here is that the radius would be the same. So the radius would still be root of 164 divided by 2. Since I calculated it like that, it appears like that right now. I can change that as well. Now what this question combines two topics together. There's transformations and there's circles. The old center is 2 comma minus 1. So the new center is going to be, if I add 8 to it and I add 4 to the y coordinate, this becomes 10 comma 3. So the equation of the new circle would be y my x minus 10 whole square plus y minus 3 whole square equals to again root of 164 over 2 whole square. So yeah, okay, and that gives me x minus 10 whole square, y minus 3 whole square equals to again 41. Okay, hoping that's the correct answer again. Then it says two circles intersect. The two circles intersect at the point R and S. So I can see that they are intersecting at R and S. Show that the equation of the line RS is y equals to minus 2x plus 13. Now I need to show the equation of this straight line that is passing through here. Okay. One thing that comes to mind is I should start solving them simultaneously. But the problem with solving simultaneously is that they're both equations of circles, and I'm going to find it very difficult to make one the subject of the other. So what I'm going to do is I will have to figure out another method for doing this. What I can notice here is that if these two circles were equal, and if this center was 2 comma minus 1 and this center was I just calculated it, that's 10 comma 3. Okay, then this equation should basically be, this line RS should basically be the perpendicular bisector of this line that is joining the two circles together. Here that property basically applies, that when you drop something from the center to the midpoint, it creates a 90-degree angle on the chord. Now since these two circles are the same, the distances should be equal, and that creates what we call here as a midpoint of these two centers, basically C1 and C2. So the midpoint of the two centers would be M. It's going to lie on the line RS, and RS is also going to be perpendicular to these two chords. The chord is going to be perpendicular to the line that is connecting the two circles together. Okay, so I'm going to say that I have C1, the center C1 as 2 comma minus 1, and the center C2 as 10 comma 4, 10 comma 3. So I'm going to first calculate the gradient of this line. I'm going to say that that's 3 minus minus 1 over 10 minus 2. So that's 4 over 8. That gives me half. Now that's the gradient of that C1, C2 line. The gradient of RS should be the negative reciprocal of that. It's also going to pass through the midpoint of these two centers. So I'm going to say midpoint is 2 plus 10 divided by 2 comma minus 1 plus 3 divided by 2. That gives me 6 comma 1. So I'm going to say y minus y1 m x minus x1. So that gives me y minus 1 minus 2x plus 12, y equals to minus 2x plus 13. So it combines your idea of properties of circles and coordinate geometry all together in one question, and that is your final answer. Then it says, hence show that the x coordinates of R and S satisfy the equation this. So if I want to find the coordinates of R and S, what I can do is, I know that this line RS is intersecting both the circles. So I can pick up any circle that I want. Let's say I pick up this one. Okay, and if I want to find the intersection points of any curve or lines, what I need to do is I need to solve them simultaneously. Since I have the correct answer from the previous question as well, y equals to minus 2x plus 13. What I now need to do is I now need to solve simultaneously. So I'm going to substitute minus 2x plus 13 instead of y, and try to see if my equation boils down to the equation that's there in the question. So this gives me x square minus 20x plus 100. Just solving inside this bracket first, 10 minus 2x whole square, just to make sure that I don't make a silly mistake there. X square minus 20x plus 100 plus 100 minus 2 into 2 into 20 is 40x plus 4x square equals to 41. That gives me 5x square. That is what I wanted. I also wanted 60x, and that's 200 minus 41, and that's 159 as well. So I have all three answers correct, 5x, all three terms correct. So that's the equation. Had I gone on and solved this quadratic equation, I would have ended up with the x coordinate of R and S. So that's the first question, a wholesome question of 6 and how many marks? 6 and 5, 11 marks. That's a lot of marks for one question. Okay, that was the first paper that I wanted to do. Let's move on to the next paper that I have to do. Okay, so that's May June 2020, and the variant is 1 2. Let's look for that question on equations of circles. There are a lot of other questions as well. Let's see another question. Okay, here we have another question. This is May June 2020 1 2. Okay, the equation of a circle with this is this. Find the radius of the circle and the coordinates of C. C is the center of the circle. So what this question is asking me to do is to express this equation in standard form so that I can find out what the center is and what the radius is. Now, if you haven't done this before, I strongly recommend that you go on and watch the lecture first, because here what I'm going to do is I'm going to try to complete this square. Everyone has a different way of doing it. I complete the square in a particular way and I'm going to just show it to you quickly. I moved the constant to the other side. What I'm going to now try to imagine is that if I wanted terms in this format, what I need is a square. I need 2ab. So what makes it 8x? I'm going to say a 4 makes it 8x. I'm completing the square for x right now. Okay, but I also need a b plus b square, so I'm going to add a 4 square to this so that it boils down and closes down into a bracket x minus 4 whole square. But since I've added something to the left hand side of the equation, what I also need to do is I need to add something to the right hand side of the equation. So that completes the square for x. Now when I'm completing the square for y, I'm going to say that again I have y square, I have 2a. The value for b should be 2 because I need a total of 4y, and I'm going to add 2 square here, and I'm going to add 2 square to the other side as well. So this gives me y plus 2 whole square equals to 5 plus 16 plus 4 is 25. So the coordinates of the center are 4 comma minus 2, and the radius is root of 25, which is 5. Okay, that's the first part of the question. That was 3 marks. You should be able to complete the squares for both x and y and come up with the final answer for this. Then it says the point P 1, 2 lies on the circle, shows that the equation of the tangent to the circle at P is this. So let me just draw a quick small diagram for you. 4 comma minus 2 is here, and the circle has a radius of length 5. I don't need to draw that. 1 comma 2, so I can imagine that 1 comma 2 must be somewhere here, or even higher. It doesn't matter where you draw it, as long as you are following what the question is saying. Sometimes it's also important to draw an accurate diagram. So that's the tangent that's passing through P. What I know about the tangent is that when you connect the point of tangency to the radius, it always creates a 90-degree angle. That's the property of a circle, that radius and tangent meet at 90 degrees. So I know that in order to find the equation of this circle, I'm going to need the gradient of PC first. So that's going to be minus 2 and 4 minus 1. That gives me minus 4 over 3. For the perpendicular, I'm going to say that I have to negative reciprocate it, 3 over 4. Then I can quickly create an equation, y minus y1, 3 over 4, x minus x1. So I get 4y minus 8 equals to 3x minus 3. 4y equals to 3x plus 5. And that's what the question wanted. So pretty simple so far. It says the point Q also lies on the circle and PQ is parallel to the x-axis. Okay, parallel to the x-axis. So I have a line that's passing through here again. Let me just copy it and put it on the next page as well so that we can see it clearly. Okay, so there is another point Q for which the line passes like that. There's a line PQ that's parallel to the x-axis. Now if it's a horizontal line, one thing that I can be absolutely sure of is that it should have the same y coordinate. So the y coordinate is certainly 2. Since it says write down basically means that the answer is pretty much there in front of you. There's minimal or at times no calculation required, so you need to be aware of that. Okay, now what I can then see is that if I were to calculate this, I know that if I drop a line here, the x coordinate here should be 4 only. Okay, and I know that when I drop a line like that, it drops on the midpoint. So I am going to say that this point in the middle has coordinates 4 comma 2, and if this is the middle, then basically this distance PM should be the same as MQ. So if this was from 1 to 4, that was 3 units. So I'm going to move another 3 units, and they say that this is going to be 7 comma 2. So I need to do no other calculations. It says write down, 1 mark is there for the x coordinate and 1 mark is there for the y coordinate. Okay, moving on. The question says the tangents to the circles at P and Q meet at T. Find the coordinates of T. Now, if I have to find the coordinates of T, T is the intersection point of two tangents. I don't have the other tangent. The other tangent is going to look something like that. I can draw it here, but I don't have the equation of this line, so I'm going to first have to find the equation of this line. Although I can sort of guess that it's going to be right above in the midpoint as well, because it's going to create a kite and all those properties would apply. But still, I don't want to guess, and what I'm going to do is I'm going to try to calculate it by just finding the intersection points, although there are other ways of calculating it as well. So gradient of QC is 2 minus minus 2, 7 minus 4, that gives me 4 over 3, and negative reciprocated gives me minus 3 over 4. What you should be able to observe is that what I am then creating is that PCQT will probably make a square. So that's something that you need to be aware of in one of the questions that comes up later in the past papers. But let's just deal with this question right now. Y minus 2 minus 3 over 4 x minus 7. That gives me 4y minus 8 and minus 3x plus 21. 4y equals to minus 3x plus 29. So I have two equations. One is 4y equals to 3x plus 5, and the other is that. So I'm going to quickly put it here. 4y equals to 3x plus 5 and 4y equals to minus 3x plus 29. So I'm going to try to solve these simultaneously. I can see that I have a direct substitution, so I'm going to use that. That gives me 6x equals to 24, x equals to 4, and that's simple then. Gives me 17 over 4. So it's 4 comma 17 over 4. And those should be the coordinates of T. I didn't realize you can see that. Let me just put that here so that I can scroll down. Okay, those are the coordinates of T. What it would have created is a square. Okay, that's the end of that question. Again, a long question. Let's see how many marks. 5 and 6. Again, an 11-mark question. So a large part of your exam. October, November 2020. Let's quickly go on and see what's there. Let's look for the equation of circles question. That's the equation of circles questions. I will have to erase this since this is already solved. Let's quickly go on and resolve this. And I think that's the tougher question. Okay. This is November 2012 again. A circle has center at the point B51. The point A minus 1 minus 2 lies on the circle. Find the equation of the circle. So when I want to find the equation of the circle, I need the center and I need the radius. The center is there in front of me, so I'm going to write x minus 5 whole square plus y minus 1 whole square. For r square, what I'm going to do is I'm going to find the radius. Radius should be the distance between the point that lies on the boundary and the center of the circle. Since minus 2 comma minus 1 comma minus 2 lies on the boundary of the circle, I'm going to say minus 2 minus 1 whole square and minus 1 plus 5 whole square. Minus 1 minus 5 whole square. So I'm going to say that becomes 3 plus 6, 9 plus 36 gives me 45. Okay. Root of 45, so I'm going to say that's root of 45 squared. So x minus 5 whole squared, y minus 1 whole squared equals to 45. Okay. Then this says point C is such that AC is a diameter of the circle. Point D has coordinates 5 comma 16. Show that DC is a tangent to the circle. Okay. Now let me just quickly jot down the things that are there. That's 5 comma 1. That's B. There's a point called A, which is minus 1 comma minus 2, which is probably here. No, further behind, I think. That's it. A was here. This says that point C is such that AC is the diameter. So C should be somewhere here. So this was minus 2 minus 1. C is on the other end. I can simply calculate C by doing the midpoint. Okay, so I'm going to first do that and then read the rest of the question. Okay, the midpoint should be 5, 1, and I can keep C as the unknown. Minus 2 plus x divided by 2 and minus 1 plus y divided by 2. That should give me the midpoint. So 5 equals to minus 2 plus x divided by 2. So x comes out as 10 plus 2 is 12. Minus 1 plus y divided by 2. So 2 plus 1 is 3. So y equals to 3. So C should have the coordinates 12 comma 3. Okay, sounds reasonable. Then it says that point C is such that AC is the diameter of the circle. Point D has coordinates 5 comma 16. Now if you notice, then I have to be careful when I sort of make my diagram as well, that D has the coordinate 5 comma 16, which means that it's basically vertically above B somewhere. So I can say that D is somewhere here. It's 5 comma 16. I have to be absolutely sure that it's here because it has the same x coordinate. What is happening is I'm asking you to prove that there is a tangent here, show that DC is a tangent to the circle. Now there are various ways that I could show it. I could create the equation of DC, solve it simultaneously with the circle, and show that there is only one point of intersection. I could also do a tangent and radius sort of situation. I could say that the gradient of BC is 3 minus 1, 12 minus 5. That gives me 2 over 7. Okay. If the gradient of DC is the negative reciprocal of this, let's find out. 16 minus 3, 5 minus 12. I have made an early mistake somewhere. I didn't notice that, and which is why the answers are coming up wrong. This was supposed to be, I copied it up wrong. This is minus 1 comma minus 2. Let's quickly do that again. I'll have to change quite a few numbers here. -1, -2, -1, so that's 11, and -2, so that's 2, and that's 4. So C is basically 11 comma 4, and that should now give me the correct answer. Let's quickly make that change. Sometimes when you make a mistake, it goes a long way. 4 minus 1 and 11 minus 5. That's 3/6. That is half. Let's see if we now get the correct answer. So 16 minus 4/5 minus 11. That gives me 12/6. That's -2. So if the gradients are, if the product of gradients is half comma half into if the product of the gradients is -1, that proves that lines are perpendicular. And you can write that since C lies on the circumference, DC is tangent. Okay, took me slightly longer because I made a mistake. It says the other tangent from D to the circle touches the circle at E. Okay, so what I'm going to do is I'm going to copy and paste this for you so that you can see it clearly on the next page. It has a bit to do with the diagram. Not a difficult question, just that you need to see what's happening in the diagram. Copy. Okay, the other tangent from D. So I'm going to say that there's another line that passes through like that. And what you now need to notice is this creates what? It creates a kite. So you need to remember the properties of the kite, that this line should be equal to this line, which means that this point E should technically be on the same level as C. I know that if this is a perpendicular line, then the diagonals of the kite meet at 90 degrees. So that tells me automatically that it's going to have the same y coordinate. And the same rule that I did for the earlier question as well, that this point is going to have the same x coordinate here. So this point is going to be 5 comma 4 basically. So the distances would again remain the same. So if this point M and C had a distance of 6 units, this also needs to have a distance of 6 units, which means that it's going to be 6 behind 5. I'm going to say 5 minus 6, which gives me -1. So the coordinates of E become -1 comma 4. Now, since this is find the coordinates, a bit of method is necessary. I would suggest that you always draw the diagram on such questions. It's easier to answer questions that way. Okay, quickly moving on. That's the end of this. Let's go on to the next here. We have March 2021, variant 1, 2. Let's see the question that we have here. And this is something that I've solved before, so I'm going to solve it again. Okay. This says the points A, B, and C are on the circumference of a circle. Find the equation of the circle. Okay. Now, if you just have points on the circumference of a circle, what you need to know is, let's first try to make a sketch of this. It's relatively difficult to imagine where the points would be. Let's just imagine that this is 7 comma 1. No, this can't be 7 comma 1 because I have to plot 1 comma 9 here. So 1 comma 9 is C. Then I can have 7 comma 9 here. That's B. And that should be about A. That's 7 comma 1. So this looks like a reasonable plot. It could have been in any other way, it wouldn't have mattered. I was just trying to show you that they are on the same level of y and these are on the same level of x, therefore they are going to be vertical and horizontal lines involved. What you need to know about the circle is, again, a very basic property, that when you drop a line from the center to the center of a chord, it intersects at 90 degrees. So when I'm trying to find the equation of the circle, I have two objectives. I need to find out the radius and I need to find out the center. Now you need to carefully observe the solution to this. If I create a chord like this, it's a horizontal line. If I create a chord like this, it's a vertical line. A property of the circle says that the perpendicular bisector of the chords will always pass through the center. The perpendicular bisectors of the chords will always pass through the center. So if I was drawing the perpendicular bisector of B and C, I know that it's going to be a completely vertical line which is going to pass through the coordinates. It's going to be the midpoint of this, so it's going to be something between 1 and 7, so it's going to be 4, 9. And vertical lines have the equation x equals to 4. So I know that this will have the x coordinate 4. I'm absolutely certain about that. Why? Because it's a vertical line. If I draw this perpendicular bisector, it's going to be a horizontal line. Why? Because that line was also vertical. What is it going to pass through? The y coordinate here is 1, the y coordinate 9 and 1. So this is going to pass through 7, 5. So the y coordinate has to be 5. So what you need to remember is that when you have 3 coordinates and I'm trying to find the center, what you need to do is you need to draw the perpendicular bisector of 2 chords and then solve them simultaneously. In my case, I didn't even have to solve them simultaneously because they were equations that were pretty straightforward. Y equals to 5 and x equals to 4. That gave me the center. The center of the circle is now 4, 5. I could use the center and any of the coordinates to find the radius. So let's say I use 7, 1. So I'm going to say that y2 minus y1 whole square and x2 minus x1 whole square. So that gives me 4 square plus 3 square gives me 25. That's 5. So the equation of my circle will be x minus 4 whole square, y minus 5 whole square equals to 25, which is 5 squared, the radius squared. Okay, moving on. This was a longer question. This was 5 marks, which took me a while to solve as well. There's a lot of space given to you as well. It says find the equation of the tangent to the circle at B. I think that should be relatively simple. You find the gradient of Bx, I keep forgetting the coordinates, 4, 5, and B was 7, 9. Or 9, 7, 9. Okay, so the gradient of Bx is 9 minus 5, 7 minus 4. That gives me 4 over 3. Perpendicular has to be negative reciprocal, so minus 3 over 4. I use the coordinates of B, y minus 9, m, x minus 7. So I get 4y minus 36 equals to minus 3x plus 21. 4y equals to minus 3x plus 57. That is then the correct answer. Okay, quickly moving on to the next paper that I have here, and that is May-June 2021, variant 1. Let's see the question that we have here. Okay, that's the question. And some of my students have already asked me these questions, therefore the diagrams are drawn here. Let me just erase them and quickly get. Okay, that is May-June 2021, variant 1-1. It says the equation of the circle is this: x squared plus y squared minus 4x plus 6y. So I'm going to move 77 to the other side, and now I'm going to try to complete the square. Now since I've learned already how to do the square, I know that I just need to rearrange these and then think of the term in B. Y squared plus 6y equals to 77. So I know that if I break this down into 2ab, b is going to turn out as 2, so I can say that this becomes x minus 2 whole square. But I would have added a 2 square on the left hand side, so that's what I'm going to do on the right hand side as well. Then this would break down to 2 into y into 3, which becomes y plus 3 whole squared. So I'm going to add 3 squared to the other side as well. I can do this in this way as long as I've learnt it properly. It's no problem to skip a few steps as long as your solution looks logical. You don't skip an essential step. Let's get our answers right. And I'm getting y plus 3 whole square equals to 90. Find the point of intersection of the tangents to the circles at A and B. So one of my students got a little confused on this one. What it simply means is that this is the circle that I'm talking about. It has a center at 2 comma minus 3. And there are 2 points A and B. Oh, okay. I didn't solve this question completely. It says find the x coordinates of the points A and B where the circle intersects the x-axis. Oh, I didn't even see the question. I could have avoided all this calculation altogether. If I want to find where it intersects the x-axis, that means y has to be 0. So I could have just solved. I didn't see this question. Okay, I could have just done this. In fact, I'll let this remain because I would want to find out the center later on. So I just need to put y0. 2 whole square equals to 90 minus 9 is 81. I can now quickly get through the question by putting a root on both sides, saying that one of these becomes 9 and the other becomes minus 9. So I get 11 and minus 7. So one of these is A, the other is B. They both have the y coordinate 0. Why? Because that's how I found out those coordinates. Okay, and then it says find the point of intersection of the tangents to the circles at A and B. So if there were two tangents passing through, let's say this is A, this is B, this is A, which one did I mark as A? Okay, this one is A 11 comma 0 and this one is B minus 7 comma 0. What I need to find out is that if there are two tangents passing like that, what is the point of intersection of these tangents basically? That's what I'm trying to find out. Okay, so I'm looking for this intersection point. Let's call that T. Okay, so I'll need the equation of the two lines AC and BC. Let's quickly do that. Gradient of AC is 0 minus 3, 11 minus 2. That gives me 3 over 9. And that becomes 1 over 3. So I'm going to use the idea of a perpendicular, minus 3. The equation of the gradient of BC would be 0, 0 minus 3 over minus 7 minus 2. That gives me 3 over minus 9. So perpendicular is 3. So one has the gradient 3, the other has the gradient minus 3. I'm going to create the equations y minus y1 mx minus x1 minus 3x minus 21 and y minus y1 mx minus x1 3x minus 33. Let's see where they intersect. Do I have more space? Yes, I have more space. Minus 3x minus 21 equals to 3x minus 33. So that gives me 6x equals to 12. So x equals to 2. I can put that in any of the equations that I want. Okay, I just want to see if that is the correct answer. Seems a little odd to me because I wasn't expecting it to turn out to be negative. Let's see. No guessing games here. 21, May June 21. Question 10 has the answer. The x coordinate is fine, the y coordinate has to be 27. Oh, I made the wrong equations. I made the wrong equations, my bad. Which is why I thought there was something wrong with it. Okay, this was AC, so I had to use A's coordinate, y minus 0 minus 3x minus 11 minus 3x plus 33, and I had to use B's coordinate here. I have written them the way they were written above, so y minus 0, 3x minus 7. So y equals to 3x plus 21. So since there was a compensating error, one of those coordinates came out fine, the other didn't. So 6x equals to 12. Now this needs to be done again. Y equals to 3 times 2 plus 21. That's 27. So 2 comma 27 is the coordinate 4. It says coordinate point of intersection, so I'm going to call that T. Okay, so that's another question down. Let's solve one more. Okay, that's another question from, it has an interesting component here. Okay, that's May June 2021, variant 1 2. That's question number 7. Okay, it says the point A has coordinates this and the line L has gradient this and passes through A. A circle has center this and radius that. Show that L is tangent to the circle at A. Okay, now let me just quickly draw that. 5 comma 11 and 1 comma 5 would appear somewhere here. I just need to show that since this is the tangent and it already has the gradient minus 2 over 3, I just need to show that this is a tangent. I could show it in two different ways. I could construct the equations, solve them simultaneously, show that there is only one intersection point and that should solve the problem. Or I could just calculate the gradient of AC and say that since they are negative reciprocals of each other and this point A is basically on the circle, I need to also prove that it's on the circle. How I'm going to prove that in a bit. Let's first just prove that. So I have to prove that A lies on the circumference. So I'm going to calculate the distance AC. See if it comes out to be root of 52. If it's equals to the radius, it proves that the point lies on the circle. So 11 minus 5 whole square plus 5 minus 1 whole square. 36 plus 16 gives me root of 52. So that is proven that A lies on the circle. Now calculating the gradient of AC, 11 minus 5 over 5 minus 1, that's 6 over 4, that's 3 over 2. 3 over 2 is the negative reciprocal of minus 2 over 3. Therefore, lines are perpendicular. Okay, so that's proven. Since it was just 2 marks, those are the two things that you need to prove. One is that A lies on the circle, and the other is about the gradient. Okay. Then it says find the equation of the circle of the radius root 52 for which L is also the tangent at A. Now there is another circle. So what I'm going to do is, let me just copy this from here, and it's saying that and what the question is telling you is that find the equation of the other circle of radius root 52. So it has the same radius, for which L is also the tangent at A. So there is another circle that also has the same tangent at the same point. So the only way that could be possible is if the circle was here. There's no other way that this was possible. Just move it to this side. I know that both circles have the same radius. So can I say that if this center was called X, the distance AX and CX would be AC would be the same? And what then leads me to the fact is that A will then be the midpoint of C and X. So can I use the idea of the midpoint 1, 5, and I'm going to say that this is X plus 5 divided by 2 and Y plus 11 divided by 2. So I've made A the midpoint of C and X. Why? Because I need to find the center. If I have the center, I can quickly use the radius and get my answer. So 1 equals to X plus 5 divided by 2. So that gives me X equals to 2 minus 5, which is minus 3. Also seems logical, it's going downwards. So 10 minus 11 equals to 5. Y equals to minus 1. So the equation of that circle would be X plus 3 whole squared, Y plus 1 whole squared, root of 52 squared, which is root of 52. Okay, that's another question from May, June 21. We'll stop here. Make sure to like and subscribe for more videos. I will be back with another marathon on further questions on equations of circles.